Alrighty, welcome. Here's a demonstration of LArVa and SimpleGraph by Angstrom Designs. LArVa is a free platform that turns an Arduino microcontroller into a data acquisition system. And this is SimpleGraph, which is an application that just shows us a nice simple graph using LArVa. To run the executable simplegraph.exe, all you need is a compatible Arduino, a cable, and a computer. The download's for free, available at angstromdesigns.com. To modify the source files and do more interesting things, the source files are included in LabVIEW, and so you'll need LabVIEW, and then included in the download is simplegraph.vi, which is the source files in LabVIEW format. Check out angstromdesigns.com for more details and for the free download. I've already got LArVa installed, and SimpleGraph is up and running. If you have problems with the install or the download, download's free, and the install, there's an install guide and a bunch of FAQs and help at angstromdesigns.com. I've got a potentiometer hooked up to channel analog 0, so that's the white line there. You can see that I'm twisting the potentiometer now. And then I've got analog 1 is tied to digital line 3, which I'll use for PWM output. So there, if I change that guy from 85 to like 150, we'll see the red line jump up. I've also got line D4 and D7 tied together, and we'll use those to explore our digital inputs and digital outputs. We're used to seeing the analog input plot. This is probably the best way to view the data, but I can also have just the raw data. So again, I'll turn the potentiometer, and we can see those values move around. Same thing holds for moving the PWM. Graph is probably a preferable way to view the data, but you have both. The bandwidth is here, so we can see the samples per second. There's also a stop button, which we'll use to end the program. If you're using the executable, that's all you'll do is to shut down. But we can also, if you're using LabVIEW and the BI files, we can use that to get to the block diagram and to see how the code is working. We can modify that for ourselves. If I come over here to the analog input, I've got the ability to turn on up to 6 analog inputs. Again, I've got 2, so all I do is enable those. They show up on the graph over here on the right, and the data values are available there. PWM outputs need to enable a line, so I've got one of the lines enabled now, digital 3, and I can just type in what value I want him to be. And if I come in here and type in 200, the analog, or the PWM outputs are 8 bits, so that goes from 0 to 255, and then the analog inputs are 12 bits, so that goes from 0 to 1023. We can actually do a little bit better than that with some averaging, and we'll talk about that when we get to the Setup tab. So continuing along, I can also do digital I/O. So if I want to do digital output, I need to just enable one of the lines. So I've got my digital output could say be on digital 4. And whenever I enable any line, the graph resets and acquisition begins anew. So the same thing will happen if I turn analog input on 7, so I can select which of the lines I want to use. We'll show now that we can use analog inputs, PWMs, digital IOs all at the same time. So for example, if I turn digital 4 on, then we can see the light on 7 comes on. These are digital inputs, so I can't click them. Once they're enabled, they just show me what the digital lines are doing. So there's, again, digital I/O turning off and on. Scaling applies to the analog input values. We can change the value for an offset. So if I don't want to go from 0 to 1023, if instead I want to go from 2000 to 3023, I can type in the offset, and those numbers will get added in here. Well, my graphs have jumped off the top of my screen, so I will need to go up and see data value 3000. So to show that value, I just went up to the top here and clicked. Additionally, we can also have a scaling value. Set this back to 0. And so if I don't want the data to be scaled by 1, instead I want to convert to some other units, maybe there's a scaling factor of 2. I can do that as well. And come back up here and set this guy back to 1023. That'll give me the full range of my A to Ds. There's a graph tab as well. We can change the axis. So right now the x-axis is time and samples, and the y-axis is volts. And we can see those are ADC voltage counts. We can see those here. So if I type in here, those things can change. And sure enough, that changes dynamically. The plot names we can also change. I've got them called A0385, just like the defaults come, and those will then be reflected here. The graph is active. This button, if I deselect this, will continue to gather data, but they won't be displayed on the graph. Similarly, I can click here to clear the graph, but another way to clear the graph is to change any of the configuration settings. I can save the data by pressing this button, and then I will get prompted for a file name to save the output data of the analog lines. The digital lines don't record their history, so those don't get saved. And then finally we have the Setup tab. The communication channel will be the channel that your Arduino is on. So there's a detailed description in the installation guide about how to get it set up properly the first time. Here's a list of the compatible Arduino boards. You'll see the megas are grayed out. Those are not currently compatible with LArVa. If you want to add another Arduino, not a mega, but another type, there is an application note on angstromdesigns.com about how to add unsupported Arduino boards. Requires a bit of LabVIEW programming, but not very much. Let's see, some of the more interesting things here. Points to average. What this number is, it's the number of samples that are averaged for every 1 point that shows up on the graph. So I can zoom in on our data here, and let's see. We can actually go. Let's do this. So if I can go and reduce, say, the number of points. So right now what I have is every point on my graph is actually 250 points that are averaged. So if I reduce that, I'll get data back that's significantly faster, but I'll get more noise. And one of the things that we've seen here is that our red line went from a relatively smooth line to a bunch of zeros and ones at different rates. Well, that's what pulse width modulation is. So this is PWM, pulse width modulation, at a duty cycle of 200. So the averaging is also what helps our PWM signal look like a continuous signal. If we were to put that into a fairly, either into something that filters or into something that responds relatively slowly like a motor, then we're doing the same thing mechanically when we're driving things with this. So again, I can put this up to something higher. Maybe I'll average 1,000 points for every point that comes in, and then I'll see that my PWM signal, sure enough, looks a lot smoother than it did before. Oh, I'm zoomed in is the reason that this looks a little peculiar. So again, I can see the graph responding a little more slowly. And if I wanted to go back and see the full range of my data, then I could turn off auto scaling for Y, and I could set this guy to be from 1023 for the top of the Y-axis and 0 for the bottom of the Y-axis. Also got a parameter in setup called loop delay, and what loop delay does is it is the delay in milliseconds between every sample. So if I want to gather data more slowly, I can increase this number. If I want to gather data more quickly, I can decrease the number. The ADCs, the analog or inputs, can return data as integers, which is the default. They can also return floating point data. What that means is if I do a lot of averaging and I'm down to the difference between 2 bits, for example 800 and 801, I could get more resolution back from floating point. With high numbers of averages, the floating point can matter. At low numbers of averages, it doesn't make a lot of difference. There's also several different references. The analog inputs gather data between 0 and 5 volts. You can also set them between 0 and 1.1 volts, or 0 and whatever you put on the AREF pin of your Arduino. It's worth noting that you should not put anything on the AREF pin until after you make this selection. Also got a couple different communication rates, so we can communicate with faster than the standard rate. And then we've got edit larva.conf. So I click this guy, I will get a pop-up, and I'll need to drag in so you can see it, where I can select a new COM channel and a new Arduino board, and that will then update the settings file. Similarly, if I want to select a new board next time, I'll stop running. In fact, I can do that now. If I stop running and select new board and run again, then I'll get this prompt at the beginning, and then the new settings that I put in here will be taken. Alrighty, if you're running the executable, that's the end of what you can do. But if you're running the source files, if you stop this and we open this up, we can actually see the block diagram. And so this is the code that runs LArVa, or actually this is the code that runs SimpleGraph, the little C-LArVa that's in here. And there's a little bit of configuration over here on the left. We find the configuration file and load the setup, set up a queued structure, and there's a little bit of memory handling there. There is a event structure. It's the first thread in our three-tiered architecture, and so you can see a couple of events in there that handle things like the configuration of the board, handling the axes, saving, naming the plots, everything that we need to do. In fact, there's the save right there. The second thread is our main thread, and that basically calls the LArVa DLL and reports the data back. Data gets passed to a queue, and there's our third thread, and this will basically take the data out, apply some scaling, and append that to the graph. If I scroll over here to the right, there's a little bit of shutdown. We write the configuration files before we shut this guy down. That's all there is. This is a fairly simple program. If this looks complex to you, you might consider learning a little bit more about data acquisition, checking out angstromdesigns.com. And there's a lot of utility materials out there. I think that's about it for the tour that we have here. We'll go into greater depth on the block diagram another time. Hope you enjoyed this, and please check out angstromdesigns.com for free download of LArVa and for the rest of your questions. Thank you so much.